Testing, recording, let's go. Okay, so today I'm looking at a Japanese scarf joint, interlocking joint, the Daimochi Tsugi. Really interesting interlocking joint, a lengthening joint that joins two pieces of timber or two beams together to make them long lay. So what's really interesting and cool about this joint is that interlocking nature of it. You know, we could have a joint, let me put this on the big screen actually, probably easier to explain. So we could have our two beams like this and have this simple joint where, you know, the diagonals are fixed and glued together like that. But what happens is we get shear force on each of these beams. And what does that mean? It means that this beam, you hide those, I'm going to sketch this bit. But this beam has all of these forces coming down on it, and forces that are pushing this beam this way and this beam this way. So over time, the glue that's holding this together might cause this beam to slip under and this slip over the top, so that they start to, you know, so that joint will fail. It's not very strong. Whereas what's amazing and beautiful about this Japanese version is this interlocking element. We have these tenons, these stub tenons on the end, and we also have this little pins and mortise that lock the joint together as well. And so what that does is all of that force that is applied along the length of that beam, you know, they're trying to move it and slide these beams on top of each other, they are stopped or dealt with by these interlocking elements. Probably best if I sketch this again on the iPad to explain this. Alright, so we're going to have a look at this Japanese Daimochi Tsugi joint and understand it a bit better through sketches. And one of the benefits of this interlocking joint, of this Japanese style interlocking joinery, you know, is that they don't use any nails or glue. It's all about these components interlocking. And the benefit of this is the joint's ability against, or its strength against, shear forces. So what does that mean? So if I just move this section out of the way for now, and I'm just going to draw very basic scarf joint diagram. Yeah, maybe we've got two beams that are cut at a diagonal like that, and they're glued together. Okay, so what we have is, on this joint, we have all of these forces pressing down. You know, maybe we've got people walking on it, there's someone's shoe there, and all of these forces are providing or giving stress on this joint, which is quite weak if it's just glued. And one of those forces is shear force. Oops. Get out of the way. No, I don't want to do that. It's shear force. So shear force, we've got the forces pushing this beam this way and pushing this beam this way. And what that is doing is this beam wants to move up because of these forces, and this one wants to slide under. And because this joint is quite weak, I just rub those out. It's quite easy for this joint to fail and slip. You know, this one to go out there, and then that bottom one to slip under. And so what we can do, or what is really interesting about this Japanese joint, is they start to introduce these interlocking elements and these more complex cuts on the diagonal. And we start to have this stub tenon, this little bit that extends from the beam, and that is slotted into this little mortise on the bottom beam. At the same time, we've got these little mortises cut, which these pins are then interlocked. And so we get these pins that add that reinforcement, and everything is interlocking. And those forces now, because of these cuts and these, this stub tenon here, these pins inside, the force that is pushing this way and wanting that beam to slip on top, the force is hitting these, this interlocking, these parts of the joint. And so what we're going to do now is practice some of our Rhino skills and model this together. All right, let's model this Japanese joint. Spilled my coffee, but got my coffee. Whoops, need to screen record. Go. All right, so I'm going to extrude that surface along the length of that. What I got? 2 meters, that'll do. So we'll start with just a plank. And you can see already I've got some issues where this grain of the wood is not correct. We want that grain of the wood to run long ways, as it does on the side of that beam. So I'm going to fix that first. If I go up into, click on it, into here, texture mapping, I can either just apply a box mapping, clear, I usually just do 1000 meter box and remap it. And you can see now that it's flipped it. So I've got the long grain on the top, and on the side it's flipped it. So what I can do is go back into our box mapping here, show mapping, and I can just use the gumball to just rotate that. Like that. So really simple. Now we've got our wood looking good. And so what we want to do now is, in Japanese joinery, they always find the center point. They like to find the center point of the wood, and what we can do in Rhino is do that as well. And so up in my layers, did it on this one, center lines, I like to create a new layer and just call it center lines. And I can draw a line from the midpoint here to the midpoint there. If I click on that, I'm just going to change that line type to dashed. And I can just copy and paste that onto the midpoint on the side profile as well. Okay, so now I'm going to draw the cutting line. I'm going to create a new layer. And just draw a polyline here. So what dimension do we have here? We've got 100mm beam. So for this little stub tenon, I'm going to do that 25. So we want to make these little stub tenons at the end of the beam to be 1/4 of the depth of our beam. So in this case, I've got 100mm depth, so I'm going to make that 20mm. And if we've got ortho on, at the bottom, we can just snap to the bottom. And I'm going to move that 200 across. I'm going to copy that 400 this way. And just move that down to the bottom. And now I'm just going to draw a line across like that. So now we can see we have, a basic scarf joint. If I extrude curve, EC, extrude curve. And then Boolean split, BS, Boolean split. Those two beams. And if I click on my cutters, okay. You can see now we've got two beams that are split. We have two beams that are split on this. Let me hide those cutters with this simple scarf joint. We've got these nibs on the top that stop the joint from slipping past each other. Stop the beam, sorry, from slipping past each other. So pretty neat. But then what we can do, or what the Japanese like to do, is interlock it even more with these little stub tenons. So they have these little interlocking bits sticking out at the end of the beams, and then also these mortise and tenons inside the beam as well. So these pins that are inside the beam that again just reinforce it and stop it from pulling apart or sliding over each other. So let's model that together now. And so I'm just going to draw another line of 20 on that center line and just move it down. So M for move, find the midpoint. If you can't see that midpoint popping up, just check your O snap and just, these tick boxes, select mid here. And I'm just going to move that down. And I'm going to rotate that in 3D, so R3, 45 degrees. Let me just hide that other beam because that's confusing me. All right, so we have our scarf. Well, let me just copy that over. So we've got our scarf joint with our nibs over there. I'm going to join this back together, so BU for Boolean union, and just join them back together. And then delete that. Oops, no, I don't want to delete that. Alright, I'm going to draw another polyline. So I'm going to start at the top here. Again, we want 20 mil down. And now I'm going to attach to the end of that little nib that I drew in the middle of that joint. Now you have, instead of just a simple diagonal cut, we've got this little zigzag in there, which again is just adding to that interlocking nature of this joint. It's stopping these joints from slipping, from pulling, and just reinforcing it that bit more. So what we're going to do now is EC, extrude curve, extrude that poly curve. Use our O snap just to pull it onto the edge of that beam. I'm going to delete that other one, get rid of that, and do the same thing. So select our beam. I'm going to do BS for Boolean split, not for the other BS. Select our cutter and just hit spacebar. And now I've got let me just change the material of that cutter. Now I've got one version of this scarf joint with the nib. Whoops. And just another version with that extra little zigzag in there that just adds to that interlocking nature of it. And so what we're going to do now is model our little stub-tenons, which are the bits on the end here that interlock into this beam. So just a little bit that sticks out. So we're going to, a little bit that sticks out, and then we'll slot into here. Same on this side, a little bit that sticks out and that slots into that part of the beam. Okay, so I'm just going to use my polyline tool again. I'm going to find the midpoint, and I'm actually just going to draw it this way, just because when I draw this way sometimes it starts to snap to other things, so I'm just going to draw it this way, easier, and then move it. So I'm going to do this one at 25 mil by 25 mil by 25 mil, and there we go. So we have this little square. These bikes are so loud. Motorbikes. Now I'm gonna move that again, focused on the midpoint. So if I just select that midpoint and move it to our other midpoint. So I have this little square. So what I want to do now is, I'm going to hide this one just so it's clearer. I'm going to extrude that curve down, and again just align it to the bottom. So now we have this little stub tenon on the end. Actually, I think I'm going to move that in a bit because it looks protruding a little bit. So maybe I'll make that 15 instead. What is it? 25, yeah. So just gonna do MM. I've set up some shortcuts that I use. So MM I set for move face. Just for speed, I'm gonna just move that face back 10 mil. So we have 15 mil little nib or stub tenon sticking out of this beam. And so what we need to do now is, you see here, this stub tenon is flat on the bottom, whereas we've already got this diagonal on the beam cut. So how can we cut out that little wedge in Rhino so that it is, you know, following this curvature, following this diagonal of the main beam? One way we can do that is, again, EC, extrude curve, and I'm just going to select that end curve. And what we want to do is just extrude that curve along this direction. So you can see when I select spacebar, it's going down in a vertical or in that Z-axis. If we go to the top here, you can see we have the opportunity to change the direction. So if I just click on direction, click once on the corner here, and then if I've got my O snap selected, this little near object snap, so if I select that, if I just hover my mouse over that line that we want to follow and just click anywhere on that line, now when I move my mouse, you can see that that plane is locked to that line. So it's going to be continuation of this diagonal. So if I just click anywhere over here, and I'm going to use that plane as a cutter just to slice off the bottom of this little box. So if I click my red box and do BS again, Boolean split, and then select our cutter, you can see now that if I just delete that cutter, that box has been split in half, and I can just delete that. So now we have this neat little stub tenon on the end of our beam, and we can just attach that now to the main beam. So if I click on our little box, click on the main beam, and just type BU for Boolean Union, and there we go, it becomes one piece. And it's all textured nicely in D5. All right. And so what do we have to do now? We've got to add another little stub tenon to the bottom of this beam. So what we can do, instead of just modeling the whole thing again, I'm just going to go back one step before I joined them. And I'm going to copy it over. Again, just working with the midpoints. Copy it midpoint here. I'm actually going to hide that cutter line for now. Using my gumball, I'm just going to rotate it 90 or 180. Also flip it this direction. And then again, just based on the midpoints, I can move that to there. And then we've got our stub tenons. So again, I'm just going to do Boolean Union there. Boolean Union there, whoops. And we have two beams. Can delete that now, delete that cutter line, I don't need that. I'm actually going to hide those center lines because they're confusing me. So what do we have now? We have our two beams with our stub tenons modeled. We've got our little zigzag in there. I don't know what the technical term is for that, to be honest. If there's any engineers or architects out there who can let me know what that technical term for that little shift is, that'll be great. But it's looking neat. So next step, what do we need to do? We need to cut out the mortise, the little hole that this little stub tenon will slot into. And we need to do that on both sides. So how do we do that? If I move our top beam down, just so that they're connected. And what I can do is just select our first beam and our second beam. And I'm just going to do Boolean split. I can't remember which one was best actually, because sometimes it deletes the actual stub tenon. Let's try Boolean split and just select the two things again. Right, yeah, so we can see that it's cut out the hole for us, but it's also split our little tenon. So I'm just going to move that one back up and just Boolean union it together again. We can delete that and just join these one. Oh, the duplication there. Delete that one and Boolean union those again. All right, simple, easy. So now we have our mortises cut, our little stub tenons sorted, and it's looking pretty nice. So the next thing to do would be to cut out our little oh, it's getting a bit messy. Hide that. Let's just go back to the end being. Next bit to do would be to cut out our mortises, our little holes inside the beam, and just model these little pins. So how can we do that? If we remember at the start, we drew these little center lines, right? If I just move that one up, oh, they're linked. Okay. If I move that center line up, I'm going to move this beam down. And actually, I'm just going to delete these ones. Don't want those. And I'm going to move this one down, lock it to the Z-axis, and just find that midpoint. All right. So our center line for the top plane, what I want to do is project that onto the surfaces. So I want it to project onto all of these faces so that I get the center line down this whole diagonal face. And so how do I do that? If I click on my line and I just type in project, up here we can say select the surfaces, polysurfaces, sub-Ds or meshes to project onto. And what we want to do is select direction to be custom. Sometimes it's just in C plane Z, but for this one I want to do custom. And we're actually going to start with this curve. And so I'm going to select my beam, my poly surface, press enter again, and now we have to dictate our projection direction. So if I just click on the end of our line and just ortho or extend it to the end, but basically we want to project it that direction so that it hits the beam. And you can see now we have this dotted line projected onto the center line of that beam. I'm getting so hot in here. Roasting. I need to turn the aircon on, but it interferes with my mic. I'm prioritizing my sound quality. All right, so we have our center line that way, and now we want to do the same thing for this one. And just select the direction to be down. And then there we go, we have, I'm actually just going to group that. Yep. Group that beam with its center lines. Actually, I don't even know why I did this one. I don't need that one. Let me delete that. That's just confusing. All right, delete those ones. We just want that center line running the length of the beam. I can do remove from group. Select those two and delete. All right, so I have my center line running down that beam. And so what we want to do is find the center point of this face so that we can cut out our mortise for our little pins to slot into. One way to do that is just, again, using the midpoints. Draw a line, and there we have our midpoint. So maybe let's stick to the same dimension for these pins as this. What was it, 25 mil? Again, just to measure that distance, and just using DI, select the point that you want to measure, and then in the top left up here you get the measurement, 25 millimeter. All right, so like we did when we cut out and we modeled these little stub tenons, we're going to do the same process down here to model these pins and then use those as cutters to extrude or extract the mortise, the hole. So we're going to use a polyline, again starting from that base, that midpoint. I'm going to lock to this center line, 25 by 25 by 25, whoops, Control Z to undo that because I snapped to this. I want it to be, you know, flat, perpendicular to the floor, 25, 25. And we want this hole, or this mortise, to be perpendicular to the top and the bottom of this beam. You know, we don't want it to be at an angle like this. Because that is just less weak in terms of joint strength. We want it to be perpendicular to the beam. And so we have our square. I'm just going to move that to the center again. And just going to extrude curve. You can see here, just extrude up or down. What we can do is actually, in the top here, we've got a few options. I can select both sides. At the moment it says no, but I can select both sides to be yes. and now it's extruding in both directions, which is good. So maybe we just want to have, I don't know, 25. That seems like a good amount. And also we want this to be solid. So if it's not solid, you can see it just extrudes kind of these planes. But if we select solid, it adds the cap on the top. So we get a solid poly surface. All right, we have a nice little pin. And I'm just gonna put that onto my dark wood layer. And I can just map that so that the materials are going in the right direction in D5. That'll do. All right, so we've got our first pin or dowel bar. Now I'm just going to copy that over again using the midpoint, lock into this ortho direction so you can see that kind of white ortho line is appearing. If I want to lock to that and not get, not get dragged over to other snapping points, I can just make sure I'm on that and then hit tab on the keyboard, and now I'm locked to that plane, that direction. And I can just snap to the midpoint. And I'm maybe going to move those down a bit so that it's a bit further into this beam. Maybe move it down 10. So just M for move, and then I can lock it in the vertical direction. I click in V or typing V. And we can move it down -10. All right, we've got our pins. Now what we want to do is just cut out the mortise, the little hole. So again, same process, I'm going to select that and do BD for Boolean difference. And now we want to select our 2 pins as the cutters. Okay. And if I just move those up, we've now got 2 holes. Can delete that curve. Can delete that curve, I don't need it. We've got 2 holes in the bottom beam that those tenons can slot into and interlock. Now we need to do the same for the top beam. So what I'm going to do now is just move those back down to where they were. I'm going to move our top beam down. And I'm going to do the same command, BD for Boolean difference. and just click in there. Where is our... Where's our little... There it is. Zoom in, click. Find our little pins to cut out. Enter, and now hopefully if I move that up, we've got our holes in the top beam. And now we have a beautiful, oops, nicely modelled, and hopefully a real good understanding of this Japanese style joint. Oh my God, I just felt a bead of sweat dripping down my face. And so, there we are. We've got our two beams slotted nicely together. We've got our two pins that slot nicely into our little mortises. And our beams that slot into each other. And there we have it, the Daimochi Tsugi, Japanese stub-tenon scarf joint. Beautiful. I hope you found that video interesting, helpful, informative, whatever. Hopefully it helped in some way. Yeah, if you enjoy videos about architecture, Japanese joinery, software, Rhino, D5, then I would love if you hit subscribe. It really helps. And yeah, follow along for more videos like this.